a tangent, if you go off on a tangent, like about why your favorite month is August, that means that you're going kind of like not towards where we want it to go, right? Okay, so a tangent in real life, when we talk about that word, means that you are drifting away from the topic. You're going on a tangent. You're going off onto a different thing. So it's kind of like an idea of what we're talking about today as a tangent. We're going to be talking about a line. You guys have to draw it. Sorry, I missed you guys. I'm so sorry. Alright, a line is tangent to a circle if it intersects it exactly one time. A line is tangent to a circle if it intersects it exactly one time. So as we take a look at this, I'm going to use orange for my tangents today. Okay, and as we look, we're looking for a line that as it comes up, it hits that circle just on the outside edge, and then it keeps going on and on past that. So it touches the circle once, and then it keeps going on. So there's my intersection point, if you want to make a point there. What? You go grab breakfast? Yeah, like 3 minutes. Speed walk. Don't talk to anyone.
I won't. I promise.
Okay. So line is tangent to a circle if it intersects it exactly one time. So okay, this is... Okay, you guys have like 5 minutes, and I'm counting. Ready?
I got you, big homie. I got you.
Oh my God, are you too?
I already got it.
Okay. Okay. Yikes. Alright, so a tangent, it goes towards the circle, it hits the circle, and then goes off in its own thing. For example, when people are bringing in breakfast into class, and people are like, breakfast. It had to do with class. It had to do with class, but then you hit that point, and you're like, okay, that had to do with class, and now we're way over here on this line, way past the point of what we're talking about. That's tangent, okay? So as we take a look at this, in this one we have a line. Our line is AB, so we do this little line with the capital A, capital B below it. And I'm using orange for that line today. For tangent lines. If you'd like to use orange also, you can. No, it's henna. Student did it. Is tangent to, now we need to name this circle. So the circle, we are going to have a little point with that little circle around the point. And we name the point that's the middle. What is this circling? Point M. Good, so circle M. Okay, now the point of tangency, this is really important. The point of tangency, it sounds really official, it's not. Remember, a tangent is a line that intersects exactly one time. The point of tangency is where it intersects. So right here is my point of tangency, point A. Okay, my point of tangency is point A. Alright, a radius using the point of tangency. So as we look at a radius, remember a radius goes from what to what? So where is my radius in this picture here? Okay, we don't know what a radius is? E. Okay. Good. Middle to outside. Thank you. Okay. Middle to outside. So R2K is our radius. Using the point of tangency, this is where I'm using blue. So our point of tangency is what point? Where does that line hit the circle? At K. All right, is perpendicular to the tangent line. Morning. So as we remember, what does perpendicular mean again? There's a little symbol there that we can see drawn in. It's what? What does that little square mean? 90 degrees. How did I get stuff on this side? All right, so what we need to decide in these next two is stuff about our tangent line. And this next one, we're going to decide if it is tangent or not. So in order for it to be tangent, we need it to be a 90-degree angle. So let's first color code this. So I have AB is my line that we're checking to see if it's tangent. So that's this one. Okay, what is my radius from what to what? So F to B or F to A? Good, F to A. So that means right here, we're checking to see if this is a 90-degree angle. That's our question mark. Is that 90 degrees? I should have written that a little bit better, sorry. And the way we can check to see if it's a 90-degree angle is by using this really famous triangle theorem that you all really remember until the day you die, but you won't remember how to use it. It starts with a squared plus b squared equals c squared. And whose theorem is it? No, it's not called Camille's theorem. Hi. Starts with P. Pythagorean theorem. But Pythagoras, remember, didn't actually make it. He stole it from one of his students. Alright, so as I look at a squared plus b squared equals c squared, remember c has to be the one across from the 90. So which side is across from the 90 degrees? The 12, 18, or the 20? 20, good. So c is 20. And then the 12 and the 18, it doesn't matter which one goes where. So we can do 12 squared plus 18 squared. And then we just have to see if those are equal. And I forgot my Desmos calculator. So 12 squared is 144 plus 18 squared is 324. Okay, now in your practice today, it's going to skip this line. So you're going to type in the 12 squared plus 18 squared. You can just put that right into your calculator. You don't have to show your work for that. You can just say 12 squared plus 18 squared equals 468. Equals, and then 20 squared is 400. So does this make a right triangle? Is that going to be a 90-degree angle? No, these are not equal. So is the line tangent? No. So your answer is no. It would be a yes if those were equal. So that's really a lot of our work today is going to be dealing with this idea that there's a triangle created here with a 90-degree angle. So we are going to be really grounded in that Pythagorean theorem today. Yep, the Pythagorean theorem.
I hate it.
Yeah, Pythagoras stole it from his student. Did you know that?
Huh?
Pythagoras' student made it, and then he was like, but I'm your teacher, so we're just going to name it after me. All right, assume WP is tangent to circle A. So this time it's telling us WP is tangent. So this time WP is for sure tangent. So we know for sure there's a 90-degree angle. What angle is 90 degrees here? P, good. Okay, and here's our radius is the 12. All right, it wants us to find WH. WH. Before we find WH, we are going to find this whole W to A. That whole length. So again, we're going to use Pythagorean theorem. A squared plus B squared equals C squared. Remember which one is going to be the C? The 16 and the 12 are the unknown. Good. C is always across from the 90. So we'll leave that C squared. And then we have 16 and 12. Morning. Here you go. No. He was just trying to quick. It was a respectful snap.
Yeah, and I put to have food in my mouth.
Okay. Hey, Mike. It was respectful until you started talking. All right. So 16 squared plus 12 squared equals C squared. Now, if you were solving this and you wanted to take your time, you could. I'm a person where I say, hey, my calculator can just do that. So 16 squared plus 12 squared equals 400. So 400 equals C squared. And then how do I get C by itself? Square root. Good. Square root of 400 is 20. But we're not done. Don't put it by your books. We're not done. Okay, this one was tricky because this is 20 is this whole length W to A. But this wasn't asking for WA, it was asking for WH. So we need to figure out if this whole length is 20, how much is this part going to be? Just making random guesses here. Holy moly. All right. So A to P is a radius. Where else do we have a radius? A to H. And in all radii, all the radiuses in a circle are the same. So how long is A to H? 12. Since this side is 12, this side is also 12. So if I know that this whole thing is 20, and this part is 12, how do I find the missing part? So we're going to do 20 minus 12 is 8. Did you just say that? I'm sorry. I got distracted because someone was swearing back here. So WH equals 8. All right, now we're done. Okay, on your practice today, a lot of it is going to be this Pythagorean theorem because this was a radius, and all the radiuses are the same.
I bet.
So AP is the same as AH.
Say that.
Okay. All right. Rest of the time is for you to get your math done. There is a new assignment.